Hello. In this video, we are going to go over this angle of elevation word problem. First thing we do is read the word problem. From a point 100 feet in front of a public library, the angles of elevation to the base of the flagpole and to the top of the flagpole are 28 degrees and 39 degrees and 45 minutes. The flagpole is mounted at the top in front of the library's roof. Find the height of the flagpole. So the first thing we need to do is draw two triangles. We have our base of flagpole triangle and we have our top of flagpole triangle. And what we need to do is start labeling. We know that this angle is 28 degrees. So we'll make that 28 degrees. We know that this distance is 100 feet away from the word problem they told us, and we don't know the height. Now we need to solve for that height. Well, the way we can do that is by knowing the rules so, ka, toa, which we are a little familiar with. Remember for this is sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Ooh, let's make sure that's a little neater. Hypotenuse. And then tangent is going to be equal to opposite over adjacent. And that's why I write it out like this with so kato with over h, a over h, and over a. So next we're going to just look at this triangle and start applying so kato. Well, with no hypotenuse, we can easily see we're going to be just using tangent. So I can set this up as the tangent of 28 is equal to x over 100. Then all I'm going to do is multiply the denominator to both sides. We see 100 tangent 28 is equal to x. We're going to plug that into a calculator, and we're going to get 53.2. And this is going to be 53.2 feet. So we know that this distance right here is 53.2 feet. So this distance right here from the bottom to the base of the flagpole, 53.2. Right there. Let me rewrite it over that. Right? So now what we need to do is find the height of the entire triangle, and then we can subtract those two heights to find the exact length of the flagpole. So now we need to start labeling the next triangle. We still are 100 feet away. We still don't know this entire distance because it's from the top to the bottom. And we do know this angle, but it has a minutes. And remember, we need to convert that minutes into degrees. All you have to do is take your degrees, 39, and add 45 minutes over 60, because we know there are 60 minutes in an hour. So we'll just take 45 divided by 60. And that's going to give you the proper decimal for that. So 39.75 degrees. I'm going to put that there. And then next, I'm going to solve for y. We're going to go tangent again, because there's no hypotenuse, of 39.75 degrees is equal to y over 100, opposite over adjacent. Now we're just going to multiply the denominator to both sides. We have 100 tangent 39.75 is equal to y. We're just going to plug that in. 100 tan 39.75. Oops. Tan 39.75. We get 80 y equals 83.2. Perfect. So that is now going to be 83.2 feet. So now let's talk about it. If this whole thing from bottom to top is 83.2 feet, and from bottom to the base of the flagpole, it's only 53. So if I were to redraw this, just to make it a little neater and make the visual a little more straightforward, is that this is the height of my building that we just found. This is the height of the building plus the flagpole. And then right here is the flagpole. So we know that this is 83.2, and then this is 53.2. Thus, subtracting those two values will give me that flagpole distance. So all we need to do is take 83.2 minus 53.2, and we see that the flagpole is 30 feet in height. So that is an example of solving for that height using SOHCAHTOA in an angle elevation word problem. If there are other examples you'd like me to cover, just please send me an email or mention in the comments. Other than that, hope everyone has a great day.